I really apologize for, I guess the weather has made my computer a little bit not cooperative today either, just as the weather is. All right, thank you for joining me this afternoon to do another webinar. This webinar is on ratio and proportion increasing in unequal ways. So let me see and get my PowerPoint going here. So as I'm getting my PowerPoint ready to work, what I would like to tell you is that if you have a question, but I've also lost that part of it too, so I'm not sure why I'm losing the screen here. Oh, here we go. It works. Okay, if you have a question, please type in the question. I will answer questions as we go on. So I really would appreciate if you have a question, please ask, please type in the question. I will answer them as we go along. I was supposed to be doing the webinar this afternoon with Frank Gardella from Hunter College, but his computer doesn't seem to be working either, so we'll get started. The objective today is to develop an understanding of the difference between a fraction and a ratio, to distinguish between a ratio and a proportion, and something that we've come up with to develop a concept of a ratio as a comparison of sets. So one of the biggest misconceptions I think that students have is that a fraction and a ratio are one and the same. So I think that's an important part of how we need to distinguish that a fraction has the properties of addition, subtraction, and multiplication, where a ratio only is multiplicative and does not possess the properties of addition and subtraction. So one of the things that Frank and I have looked at in the way we start to develop lessons is that lessons should be developed in 4 major ways. The students should be able to do things kinesthetically, using manipulatives, being able to visualize what they're doing. Then we need to look at the language of the mathematics. What is this language and how do we put it together? Math is a language, so looking at the language of the mathematics. Making a connection between the concepts and what they're doing with the manipulatives. And then the last but not least is symbolic. How do we take this and turn it into the mathematical symbols, the symbolic notation? When I teach algebra, I tell my students that if we look at a word problem, that's the language, and then we have to take that language and we have to make a connection between the language and the symbolic notation. We're taking it and putting it into the symbolic, the mathematical language, the symbols. So if you look at the research on ratio and proportions doesn't seem to have a whole basis of what we teach in ratio and proportion, but they are a very important underpinning of higher forms of mathematics. It's that ability to understand the concepts that students can solve problems and understanding situations between quantities. It's a comparison between quantities. I think students need to understand this important mathematical tool. So ratio and proportions are an important part of mathematics, the fundamentals. So if we look at what has been said, we view proportional reasoning as a concept on the one hand, it is the capstone of children's elementary school arithmetic. It's what they learn at the end of arithmetic. And on the other hand, it's the cornerstone of all that follows. It's very, very important when they get to algebra, when they get to calculus. So it's a really important tool. So what is the difference between a fraction and a ratio? What is the difference? Let's think about that. A fraction is a number that names a part of a whole. The denominator represents the total number of equal parts that the whole is divided into. So can everybody hear me now? Okay. All right. I don't know what happened, but okay. So let's start back. A ratio is a comparison of two quantities that do not always follow the same rules as a fraction. Fractions can be added, subtracted, multiplied, and divided. Ratios cannot be added or subtracted, especially if we're looking at the comparison of quantities which are not the same. A ratio does not always mean the part to the whole. So this is an important concept that students have to understand. If we talk about the ratio of boys to girls in a class, 3 to 2, for every 3 girls in the class there are 2 boys. We're not talking about a part of the whole. So we can look at miles per gallon, how many miles I've traveled on a gallon of gas, miles per gallon. We can talk about if I'm going to take a walk and I know that I can walk at 2 miles per hour. That's not a part to a whole, that's a ratio. It's a comparison of two quantities. So therefore, the students need to very basically understand that a ratio is not always a fraction. Can everyone hear me? I'm getting something that it says I've muted myself. Okay, all right, just as long as everybody can hear me. Okay. Okay, so the Common Core's mathematical practices talk about, again, let's make sense of the problem and persevere solving them, reason abstractly and quantitatively, construct a viable argument, and critique the reasoning, model with mathematics. And I think that's an important part in mathematics. How do we take this kinesthetic modeling and change it to the language, change it to the symbols, and get them to understand that fundamental concepts? So the 8 mathematical practices through mathematics are very, very important. That's the underpinnings, again, of our Common Core standards and how we need to develop the tasks and the problems that the students will be doing so that we can really understand their fundamental understanding of the problems and the concepts. All right. If we look at the mathematical proficiencies, which go way back, conceptual understanding, which is the comprehension of the mathematical concepts, operations, and relations. Okay. And the procedural fluency of the skills and character, that pertains to the rigor of the standards. That pertains to the rigor of the standards, that conceptual understanding and that procedural fluency. That's a very important part, because remember, one of the three major parts of the Common Core are coherency, which is the flow of the concepts, the standards from grade level to grade level, the rigor, which is that conceptual understanding and that procedural fluency, and the focus, that the standards are very focused on the concept. Okay, and these are the other proficiencies: adaptive reasoning, productive disposition. Okay. Before grade 6, ratio and proportion, if we look at the standards, is really not discussed. It's in grade 6 and grade 7 where we start to look at the standards. So before grade 6, do we introduce ratio and proportion? Yes, we do, but maybe not in the way you would introduce it in grade 6 and 7. So you can start with the understanding because of what is a ratio, that it is a comparison of two quantities. Because in grade 6 they start to talk about the ratio as a rate. They talk about it with multiplication and division. They talk about being able to recognize multiples of ratios, equivalents in ratios. So that's the important part of being able to understand in grade 6. But what happens before grade 6? I'm going to show you a video that we created to start the students in grades 3 and 4, to look at what is a ratio, but not in a formal sense. So I'm going to show you this video of how we view the beginning parts of teaching ratios in the early grades.
We are going to look at how to match things in an unequal fashion. In this example, we're going to use apples and oranges. For my apples, I'm going to use red chips, and for my oranges, I'm going to use orange chips. And in this case, we're going to match 2 apples and 6 oranges. Let's do that again. Again, the way I'm doing it is I'm going to match 2 apples and 6 oranges. So now I have 2 sets of 2 apples and 6 oranges. I have one here and I have one here. But I could also say that I have 4 apples and I have 12 oranges. Let's do it one more time. I'm going to take a set of 2 apples and I'm going to take a set of 6 oranges, because we are giving out the apples and oranges as 2 apples and 6 oranges. So now I have 3 sets of 2 apples and 6 oranges. I have one set here, one set here, one set here. Or I can say I have 6 apples and 6, 12, 18 oranges. Now what happens if we want to say that we want 14 apples? So let's put 14 apples down. So now we have 2, 4, 6, 8, 10, 12, 14. The question is, if we're handing out oranges and apples at a rate of 2 apples and 6 oranges, how many oranges are we going to have if we have 14 apples? Well, let's match up the oranges to all the apples that we have. So we're going to take another set of oranges and put it with this set of apples. We're going to take another set of oranges and put it with this set of apples. We're going to take another set of oranges and put it with this set of apples. And finally, we're going to take another set of oranges and put it with this last set of apples. So now we have our 14 apples, which we had before, and now we've matched up each of these sets of apples with 6 oranges. And the question is, how many oranges do we have? Well, we have 6, 12, 18, 24, 30, 36, 42 oranges. Another way of looking at this is we have 7 sets of 2 apples. That's going to match up with 7 sets of 6 oranges. 7 sets of 2 apples is going to be 14. 7 sets of 6 oranges is going to be 42. So if we have 14 apples, we are going to have 42 oranges. And the reason that is happening is because at the beginning, we matched up a set of 2 apples to a set of 6 oranges.
Being a comparison of a set. We talked about 2 apples to 6 oranges, and we talked about it increasing, and if you increase it, it's looking at it as a multiplicative. And we saw that if we had 7 groups of apples, that would have given us 14, and 7 groups of oranges would have given us 42. So the comparison there, then if you look at it, is 2 apples to 6 oranges, a set of 2 to a set of 6. So we're looking at being able to introduce those as sets, a comparison of sets. I'd like to show you now a NAEP. Here is a item from NAEP, which is again 4th grade, and it talks about a 4th grade class needs 4 leaves each day to feed its 2 caterpillars. How many leaves would it take to feed 12 caterpillars? Well, if we look at what that video just talked about, the ratio is 4 to 2, 4 leaves for every 2 caterpillars. Now, we need to feed 12 caterpillars. I could also say that it's 2 caterpillars for 4 leaves. So we're looking at the set of 2 caterpillars to a set of 4 leaves. So in a 4th grade, if we wanted the students to model that, this is what it would look like. Here is my sets, my set of 4 leaves to 2 caterpillars. So if we look at it, for 12 caterpillars, I have 6 times 2, and I would have 6 times 4, 24 leaves. So if we look at it, you have a modeling, a drawing, which the students can do. Looking at this to draw this, to model it. So we're looking at this ability of a comparison of sets. We're looking at 4 leaves to 2 caterpillars, a set of 4 to 2 caterpillars, a set of 4 to 2. So we're looking at this solution, and it's a way of getting students to understand that it's a comparison of quantity without having to be of the same dimension. We're not talking about caterpillars to caterpillars or leaves to leaves. We're talking about leaves to caterpillars, making a distinction of the difference between a fraction and a ratio. Here's a problem that I have done with students in my graduate class when I teach a graduate class for getting a master's in teaching. So this is a problem I have done. I've gone into and also did it with students in the school. And the way I do this is I have a very huge hand, and I tape it to the wall, and I say to the students, or how to introduce this. I I kind of do a little play on this. I say, oh, there's a hand. Someone came in and took the cookies that we had in the cabinet, and we want to know how this hand is awfully big. How could we find out how big the person is who took our cookies? So this actually comes from Ames. It's a problem that comes out of the Ames series. And so I've taken it and I've kind of modified it a little bit. And we look at this, and I've done it with third graders, I've done it with seventh graders, I've done it with eighth graders. This is a problem that you can expand and use at different grade levels based on how you want them to come up with a solution. So if we look at this and we say in a third and fourth grade, how would a student do this? Let's think about how a third and fourth grader who really is not sure about ratios yet. So how can we do this? Well, let's look at a possible solution. Here is a solution. You know, how big is the giant? So they can take their hand and put it up against the giant's hand. And we notice that here is Holly's hand, and four of Holly's hands make one of the giant. So when you're looking at this, I've got a ratio of 4 to 1, 4 of my hands to one of the giants. So basically you're saying in the third and fourth grade, that's a pretty big giant, pretty big person, if 4 of my hands make up one of the giants. We're going to revisit this problem as we get later on in the webinar to see how you would do this and how you would come up with a solution based on different grade levels. So this is a problem that you can use at different grade levels, and again, it gets to the same concept. Okay, so here is where the ratio and proportion starts in the Common Core. It starts in grade 6. Grade 6 is where you start, but I think that doing it in grades 3 and 4 and even grade 5, when you start looking at problems and getting them to understand the concepts, because that's the coherency in our standards, the coherency of being able to look at how it goes across the grade levels, so getting them to start to understand what is a ratio. So again, it's understanding ratios to solve problems. Understand the language of a ratio, that it is a relationship between two quantities, not a part to a whole. So as we did in the video and as we did in that diagram, we talk about it as being a set, a comparison of a set of 2 to 4 or 2 to 6. We're talking about it as for every 2 apples there were 6 oranges. For every 4 leaves I can feed 2 caterpillars. So again, that idea that it's a set of A to a set of B. Okay. Here's another problem, which would be more on a 6th grade level rather than a 3rd and 4th grade level. If a bag of marbles is 3/5 of the marbles are blue and the rest are red, if the number of marbles is doubled and the number of blue marbles stays the same, what fraction of the marbles will be red? Okay, so again, we're now getting into a bit of, here's a fraction. Here's a fraction. So we know that if we talk about a part of a whole, if 3/5 are blue, then 2/5 have to be red. But we're saying now if we double the number of blue marbles, double the number of red, and blue stay the same, what is the fraction? So think about how you would do that and how we can change that problem up to talk about ratios, how we can change that problem up to actually talk about it as being a ratio. Okay. All right. Given that 3/5 of the marbles in the bag are blue, then that means that 2/5 are red. we can see that the ratio of blue marbles then would be 3 to 2, taking it from a fraction to a ratio. For every 3 marbles I have, for every 3 blue marbles I have 2 red marbles. So now we're not talking about it as a fraction, we're talking as a comparison of red to blue or blue to red. Okay, so if we double the number of red marbles, then that means I now have 4. And the ratio would be 3 to 4. 3 to 4. The blue marbles stay the same. The red marbles are double. So now I have a ratio of 3 to 4. So now if I wanted to know what part of my blue marbles are in the bag, it's no longer 3/5 or 3 out of 5. It's 3 out of 7, and the red would be 4 out of 7. I think that becomes a real confusing part with students when we talk about a comparison of a quantity to a quantity without talking about it as being of a whole. Talking about the rate here of being 3 to 4, which means that the total in the bag would be 7 marbles, and that's where students become a little bit confused about the ratio versus a fraction. We're talking about quantity to quantity, not part to a whole. But I can change it to a fraction by stating now that if I have 7 marbles in the bag, then I would have 4/7 red, 3/7 blue. I think one of the things that students need to understand, that if I have 3 to 2, that would be a total of 5. If I have 3 to 4, it would be a total of 7. So looking at that, I think, is an important part of how we introduce sometimes the ratio versus the fraction. Okay. One of the things that also, when you deal with the ratios, a ratio talks about using real-world problems and being able to set it up in a table or equivalent ratios, diagrams, and I think that's an important part too. What we did when I showed you the 3rd and 4th grade, when I did those problems, we used diagrams. When we looked at the video, we started to look at it as being a table, looking at, but using manipulatives to do it. So we're going to look at that video in a different way right now, where before it was the kinesthetic, and now we're going to look at it through the language part, getting the students to understand the language of a ratio. So as I stated before, we look at teaching concepts through the kinesthetic, the language, making a connection to the symbolic. So here I want to show you the video in a different light.
We're going to look at matching things in an unequal fashion. In this example, we're going to use apples and oranges. And what we're going to do is we're going to match 2 apples for every 6 oranges. So let's record that. We have 2 apples, and we're going to match that with 6 oranges. Let's get another set of apples and oranges. So we're going to have a set of 2 apples and another set of 6 oranges. So now we have 2 sets of 2 apples and 6 oranges. We have one here and we have one here. But another way of looking at this is that we actually have a total of 4 apples and a total of 12 oranges. So what we're going to do over here on our mat is record the total. We're going to record the totals as they appear on our work map. So now we first had a total of 2 apples and 6 oranges. We now have a total of 4 apples and 12 oranges. Let's do it again. We put another set of 2 apples and we put another set of 6 oranges. So now we have 3 sets of 2 apples and 6 oranges. We have 1 set here, 1 set here, and 1 set here. But over on our recording, let's record the total number of apples and the total number of oranges that we have. With the apples, we now have 6 apples, and those 6 apples match 6, 12, 18 oranges. So 6 apples match 18 oranges. Now let's look at a problem. What we want to do is we're going to develop a set of 14 apples, and we're going to find out how many oranges we need to be shared out unequally to match those 14 apples. So what we're going to do is we're going to create our set of 14 apples. We have 6 already. I add another 2, that gives us 8, and I can record the total number of apples there. I put another set of 2 apples, that gives us a total of 10 apples. I give another set of 2 apples, that gives us a total of 12 apples that I record in the totals. And finally, I get to my 14 and a half, and I'm going to record that in my totals. Now the question is, how many oranges do I need to match up with these 14 apples? So let's start adding sets of 6 oranges. I add 1 set of 6 oranges. I have 8 apples here, and I will have 6, 12, 18, 24 oranges. So 8 apples matches 24 oranges. I match up another set of apples and oranges. I have 2 apples here. I match it up with another set of 6 oranges. So now on the left, I have 2, 4, 6, 8, 10 apples right there. And that's going to match up with 6, 12, 18, 24, 30 oranges. So 10 apples match 30 oranges. Again, I'm going to add another set of 6 oranges to match up with this set of 2 apples. So now I have 2, 4, 6, 8, 10, 12 apples right here. That's my total number of apples. And the question is, how many oranges do I have? I have 6, 12, 18, 24, 30, 36 oranges. And finally, I add in another set of 6 oranges to match my last set of 2 apples. Now I have all 14 apples as a total. And the question is, how many oranges do I have as a total? 6, 12, 18, 24, 30, 36, 42. I have 42 oranges. So if I want 14 apples, and I'm giving out the apples and oranges, a set of 2 apples for a set of 6 oranges. If I have 14 apples, I need 42 oranges to match up with my 14 apples. And again, the reason for doing that is that I'm handing out the apples and oranges at a rate of 2 apples for every 6 oranges.
So if we go back to the video, it's talking about taking and comparing the sets, set of 2 to the set of 6. But now it's taking, instead of just looking at the manipulatives, making a table, increasing it by apples by 2, oranges by 6. And if we notice the pattern, we notice that if we take 7 groups of 2 and multiply it, we get 14. 7 groups of 6 will get 42. So we're looking at the ratio of being multiplicative, not additive. So that's what we're looking at here. So when we start to look at this, we're looking at setting up a table, going from the manipulatives now to a more formal of a table. So if we look at this problem, it states, John and Will ran for 6th grade class president. There were 36 students voting. John got 2 votes for every one Will got. How many votes did each get? So the ratio here is 2 to 1. So the students could start doing this by setting up a table. So we're looking at getting them to look at the patterns of how to solve problems, looking at the underlying concept that for every 2 votes that John got, Will got 1. So how would we set this up? How would we solve this? So let's think about how you're going to solve this type of a problem. So if we look at the solution, one approach to using this is a table. So for every 1 vote that Will got, John got 2. So if Will got 5, John got 10. But you notice that in the 3rd column, there were only 36 students. So we have to remember that it has to total to 36. And again, it's getting them to understand the relationship 1 to 2, 5 to 10 is actually 15 total. 10 to 20 would actually be a 30 total of votes. So if we look at this, we can see that, and I didn't set this up where it went 1 to 2, 2 to 4. I set it up with an increment that's a little bit different. But if we look at this, if the student set it up as going 1 to 2, 2 to 4, it would be the same. It's correct. It's how they're going to set it up, how they're going to look at the problem. So we're starting to get them to look at the comparison of quantities and to get them to understand what the total is here. 5 votes for Will, 10 votes for John gives us a total of 15 votes. 12 votes for Will, 24 votes for John would give us a total of 36. So we're going now from manipulatives to more of a formal type of solving the problem by looking at a table. So one of the standards talks about being able to set up tables, looking at line diagrams, looking at how we can solve problems by, again, looking at a visual type of a solution. Here would be another problem with, so here we have a problem. We're talking about a mixture. You're going to make a punch. You're going to make a punch. And it tells you that for every 3 cups of apple juice, I'm going to add 2 cups of grape juice. So this punch has a ratio of apple juice to grape juice of 3 to 2. So it tells me that I'm adding 5 cups into my mixture, 5 cups, but it's 3 cups of apple juice to 2 cups of grape juice. This is using a line diagram to look at it, the rectangles representing each cup. So we're looking at it again through a visual. Each rectangle represents a cup. So I can say that the apple juice is 3/5 of the mixture and the grape juice is 2/5 of the mixture. So again, it's getting them to look at something visually and then taking it and putting it into the symbolic of the mathematical expression of 3 to 2. So then if we wanted to say I wanted to double the recipe, then I would have to have 6 cups of apple juice and 4 cups of grape juice. So looking at how so it says if this amount of juice is 1 gallon, suppose I wanted 4 gallons. Again, looking at being able to set this up in a table form, or looking at using the rectangles to say that's 1 gallon, how many would I need for 4 gallons? So taking all of this and getting them to understand that if I have 4 gallons, I'm going to multiply it by 4. I would have 12 cups of apple juice and 8 cups of grape juice. And again, to start them to get to understand that the ratio of 3 to 2 and 12 to 8 would be the same. So now we're starting to get them to understand equivalence in ratios, equivalence. So we're starting to look at how we're getting the students to be able to move further on in their concept and understanding of a ratio as being different than that of a fraction. Okay. Did I go? Okay. Here's another problem using something similar, and a problem that is used in most classes that that's pretty much a standard problem. It says Alice, Raul, and Maria are baking cookies together. They need 3/4 of a cup of flour and 1/3 cup of butter to make a dozen cookies. They each bought ingredients from home. Alice bought 2 cups of flour and 1/4 cup of butter. Raul brought 1 cup of flour, 1/2 cup of butter, and Maria bought 1 1/4 cups of flour and 3/4 cup of butter. If the students have plenty of the other ingredients they need, such as sugar, salt, baking soda, and so on, how many batches of a dozen cookies can they make? So again, we're looking at all of this to determine that we have 3 cups of flour and 1 cup of butter to make a dozen cookies. Now I have all of these ingredients. How am I going to figure out that it's 3/4 to 1/3, 3/4 cups of flour to 1/3 cup of butter? So how do we figure this out? So now we would have to start to look at asking the students, what do you think the first thing we need to do here? What's the first thing that we need to do? I think the first thing we need to do is find out how much flour we have, how much butter we have. So again, we're relying on some of the concepts that they learned about fractions, how to add these fractions. So if we look at the solutions, it says what the children brought from home. So we have the 2 cups of flour from Alice, the 1 cup of flour from Raul, and the 1 1/4 and the 1 1/4 cups of flour from Maria. So the total is that they have 4 1/3 cups of flour. Then if we figure out how much butter they have, again, by adding what they are. So here again, if we look at it, if you need 3/4 of a cup of flour to make a dozen cookies, well, how many 3/4 of a cup are there in 4 1/4? It says you can make 5 2/3 batches of cookies based on the amount of flour. So if we look at now the butter, adding again up the butter, and we figure out how much butter they have. So if we look at it, it states that they have enough butter to make 5 2/3 batches. So if you figure it out, they can make 4 1/2 batches with the butter. So they don't have enough butter to make another batch. So basically they can only make 4 batches of cookies based on the amount of flour and the butter. The butter here is the limiting factor. They only have enough to make 4 1/2 batches based on the butter. Excuse me. So again, it's looking at the comparisons of quantities, flour to butter. So again, we're comparing, and in a fraction, again, we would be comparing flour to flour, butter to butter, but now we're comparing flour to butter to make our cookies. Okay. In grade 7, they start to talk about proportional reasoning, again, adding another dimension to what is a ratio. They talk about computing it as rates, a ratio is a rate. And again, with different units of measurement, recognizing that proportional relationships between quantities. What is a proportion? A proportion is the equality of two ratios. So we're taking and we're adding another dimension, that this ratio is the equality of two ratios. And again, looking at how do we determine that these are equivalent ratios, by looking at, again, a table or by graphing. And a rate, when you talk about a straight line, you're going to start introducing a concept that in our webinar on algebra we'll start to talk about a little bit more when we start looking about slope. Slope is a rate of change. So in grade 7, you're starting to introduce that concept that the ratios can be a rate. And again, looking at it through a straight line, and what does that line mean? It's a constant rate of change. So starting to look at getting the students to develop a notation and a concept that you will start to talk about in algebra. So this is that coherency, again, in our standards, of being able to move through the standards and building upon certain relationships. So again, I'm going to show you another video which will start to talk about that.
We're going to match things in an unequal fashion. In this example, we're going to match up apples and oranges. And we're going to match them up in the following way. We're going to match up 2 apples with 6 oranges. And we're going to record that. So we're going to record that we have 2 apples and 6 oranges. Let's do that again. We're going to take another set of 2 apples and another set of 6 oranges. So now we have 2 sets of 2 apples and 6 oranges. We have a set of 2 apples and 6 oranges here. We have a set of 2 apples and 6 oranges here. But there's another way of looking at this. Here we have a total of 4 apples. Here we have a total of 12 oranges. And what we're going to do on our SmartPal is we are going to record the totals. So we're going to have 4 apples and 12 oranges. Let's do it one more time. We're going to have a set of 2 apples, and we're going to have a set of 6 oranges. So now we have 3 sets of 2 apples and 6 oranges. We have one here, we have one here, and we have one here. We can also look at the total. The total number of apples is 2, 4, 6. So let's record that. The total number of oranges is 6, 12, 18. So let's record that. So we're sharing out things, a set of 2 apples and a set of 6 oranges. Now what happens if we want 14 apples? How many oranges would match up with 14 apples? So let's create the 14 apples. There's 8. There's 10. There's 12. And there's 14. So there are my 14 apples. And the question we wish to ask is, how many oranges will match up?
In the matter of time, because I know the time is getting limited, when this webinar is posted, you will be able to look at the videos. So I'm just going to move on because there are other concepts that I want you to talk about in the remaining time. So this is again talking about being able to go to the symbolism, again talking about it as being a set, and looking at students and presenting things in different ways so that they can see a pattern. So I'm going to move on and look at going back to the giant, again looking at this hand, but now doing it not with saying that 4 hands to 1 hand, so the giant is really a big person. Start to looking at it as a measurement. Looking at it by saying, if I measure my hand, and I know that my hand, one of my hands to my height, we're setting up a proportion. The measurement of my hand to the measurement of my height. Looking at the measurement of the giant's hand to the giant's height. So we're looking at measurement now of a hand to my height, a hand to my height. We're setting up the measurement, we're setting up a proportion. So we're looking at being able to move it to the new level, looking at it from a different perspective of knowing more about ratios and more about proportions. So coming up with a different solution. Here would be another one, moving it across the floor, again using a tape measure by saying that if 10 of my hands make up one of the giants, and this is my height, how much would the giant? I've also done this type of an activity, but not with the hand, with changing it around for older students by using a footprint. Saying it was at a crime scene or someone came into the house and took something, and using a footprint and tracing your foot, again finding our foot to their foot, changing it up and using same concept of being able to set up a proportion of the size of my foot to my height. Also making a drawing if we decided to looking at the heights of children and the size of their foot, by looking at proportionality, by setting it up that way, is comparing if, looking at a graph, looking at the points on a graph and using it as a graph, the size of my foot to my height, the size of someone else's foot to my height. But that also would introduce them to the fact that the ratio of my foot to my height should be pretty much consistent among, may not exactly, but then again we start to introduce things that the Common Core is starting to introduce in algebra, that we don't really live in a linear world. We live in something that's not totally linear. So starting to get them to understand this a little bit, that these lines are somewhat straight, not totally straight. So using it that way, being able to look at looking at this problem at a grade level appropriate solution. So looking at it in a different light from a 4th grade versus that of a 7th grade, looking at coming up with the solution in a different manner. But the concepts are the same, looking at a ratio, now a ratio versus a proportion, find my solution. Okay. So as I said, they talk about being able to draw a line, set up points, and to come up with a unit rate and a line would be the grade 7 standards for the Common Core on ratio and proportion. I'm going to present now an activity that I have done in many of my classes, and this is who's got speed. So, John and Mike were discussing who has the faster car, and they decide to have a race. So they line the floor with Unifix cubes and a tape measure, and they mark off a distance. And I've done this with, you take 2 cars, 2 battery-powered cars, or I've taken a battery-powered car and a push car to show the difference of the speed and which one would be faster and which one is a little bit more consistent, the one with the battery. So getting them to start to look at distance versus time, which is another way of being able to talk about a rate, distance versus time. So we start by, we line it with Unifix cubes or a tape measure, and we have a stopwatch, and we look at, students lining up and having them mark off the time for 1 Unifix cubed or 2 Unifix cubes and how far the distance is by measuring the distance based on the Unifix cubes and using a stopwatch to measure the time versus the Unifix cubes. And being able to come up with how are we going to determine this, how are we going to validate this, and again, looking at a graph. Looking at a graph might be a way of looking at how we validate this. So if we come up with a table, here's one way of looking at the solution. Here's one way if we look at the solution here by saying here's the time in seconds, the distance in inches as measured by my tape measure. Having them look at this, and the change in distance, looking at the change in distance, which starts to get them to look at this as a rate, the change in distance over time. So looking at it as a rate, taking these points and putting them on a graph to see if I look at this on a graph, which would have the steeper incline, how can we use that to talk about, again, getting them to talk about what they're doing here, looking at how they can validate their answer by looking at this graph. So we're moving from what we've done in 3rd grade to start to introduce the concept of rates by looking at how many leaves we can feed, 4 leaves for 2 caterpillars, looking at apples to oranges, again, not the same quantities. Here we're comparing time to distance. For every 1 second, I went 3.2 inches. For 2 seconds, I went 6.4. For 2.5, I went 8. What would be, again, looking at this table, if we only did the first 3 and it was pretty consistent, what would it be for 4? What would it be for 5? Again, being able to rationalize that this is increasing at a constant rate. The inches, the distance is increasing consistently. How can I fill in this table? Plotting the graph and then looking at this as equivalent ratios, setting up the proportion maybe to find if I went in 2 seconds I went 6.4 inches, how many, if for 4 seconds I would go, how many, setting up a proportion to be able to solve for that variable. So looking at it in grade 7, moving it on to grade 8 would be being able to talk about this rate of change as being a slope. So again, looking at proportions in a different light, the comparison of 2 quantities as miles per gallon, apples to oranges, leaves to caterpillars, time, distance to time. So again, showing that a fraction is not, a ratio is not always a fraction. A ratio is not always a fraction. Could a ratio be a fraction? Yes, we saw that with the marbles when I talked about the number of blue marbles versus red marbles. 3/5 were blue, 2/5 were red, doubling it, changing the whole, looking at it, but saying it's the ratio of 3 blue to 2 red, then becomes 3 blue to 4 red. Looking at it as a ratio, looking at it as compared to a fraction. So that's all I really have today. And when I stated as we go on to the algebra, we were looking at the ratio as a slope at a rate of change. Are there any questions that you would have? The chat was open. I didn't see any questions. I was looking. Is there any questions that anybody would like to ask now?
Jade. Okay, good job. Ready to carry a message up here. Open message. 81 unrelated numbers. You don't have to memorize them. They cannot be written down. When you get together,
I can't.
Massachusetts. What does it mean with someone?
I can't hear you. It's coming through as. It's coming through very garbled. I can't understand the question. If you could type it, it might be better.
I just unmuted Helen. She had her hand up. Helen, you're unmuted if you have a question.
Not yet. I'm still trying to figure out.
No question? Okay.
Okay. I don't see any questions. I will give you again my email or Frank's email, and if you have a question, please do not hesitate to email me or Frank. We would gladly answer any of your questions, any comments, any information that you would want, gladly. So here's my email and Frank's email, and I thank you for participating. I really appreciate it. So as I stated, any questions, the videos you will be able to watch, the one that I stopped in the middle, you can watch that when the webinar is posted. They will be there. So any questions, that would be great. Well, thank you again, and where is the webinar going to be posted? I know Alexandra will send you the link. The last one was posted on YouTube, and so you know, the last one, the one that we did on fractions, was posted on YouTube. So they will send you a new link. Okay. Thank you, everyone. Have a good afternoon, and be safe.